Good day, students. Today we're going to look at another in the series of hypothesis testing. So let's get right to the problem and see what we're working with here today. Researchers want to test the effectiveness of a new anti-anxiety medication. In clinical testing, 64 out of 200 people taking the medication report symptoms of anxiety. Of the people receiving a placebo, 92 out of 200 report symptoms of anxiety. Is the medication working any differently than the placebo? Test this claim using a significance level of 0.05. Alright, now, first of all, what type of problem is this? Well, you should recognize we weren't given any means or standard deviations. We're only given proportions. Look, here's a proportion. 64 out of 200, that's the medicated group. So in the medicated group, right, I have a p hat, which is the proportion of a sample, is 64 out of 200. And if I look at the second one, I see 92 out of 200. So in the placebo group, now placebo is the fake drug, right? Looks like the same as the medicated drug, the real drug. The people don't know they're taking it, and that's often done in when you're doing clinical testing like this with medications, okay? So the placebo group is the fake drug. They don't know it's fake though. And that's 92 out of 200. So let's call this P2, P hat 2, and we'll call the other one P hat 1. So what type of test do we call this? We call this a two-sample proportional test. Two-sample prop is abbreviated, and it's a z-test because all proportional tests we use z-tests. Okay? Now some people don't write it like this as a ratio or proportion. They write it like this. They'd say, well, x1 is 64, the number of successes, out of n1, the number of trials, which is 200. Right? So they might write it like that. x2 is 92, the number of successes, out of n2, the number of trials. So either or is quite fine. Now, the fact that our sample sizes are the same is not significant, okay? That's common in clinical testing. However, people drop out of, they never turn out to be equal usually, and we don't need them to be equal to run this test, okay? So that's just in this particular problem. Now, so let's go through our 5 steps. The null and alternate hypothesis. Step 1. Well, I look at the wording right here, and I see, is the medication working any differently than the placebo? In other words, is there any difference between the population proportions? Okay? And in a proportion test, you're testing the population portions of each, right, of each group. In the other test, other tests, the t-test and other z-tests, we often are testing the means of two groups, right? But now we're testing the proportions of each population. So we would write it, instead of mu1 not equal to mu2, we would say p1 not equal to p2, okay? Now, so because working any differently means, is there any difference between the means? And we know that phrase will always mean p1 not equal to p2, and therefore, therefore the null hypothesis P1 equal to P2, right? The status quo. Are they equal? Are the proportions of the populations equal, or are they different? So in other words, is there any difference between the medicated group and the placebo group? Now remember, always don't forget, the null hypothesis always contains the equal sign, which we have done correctly in this case. Another thing to watch for is the fact that a lot of textbooks use pi for the symbol of a proportion of a population. So pi 1 equal to pi 2 would be perfectly correct, or pi 1 not equal to pi 2. Okay? And because it's not equal, therefore, what type of test do we have? If you see that, two-tailed test, right? It's a two-tailed test. Which means if it's two-tailed, our area for two-tailed is what? What's the area for two-tailed? The area for two-tailed is alpha over 2, right? Whoops. Just try that again. So alpha over 2. Alright, so it's two-tailed, alpha over 2 is the area. Now, the next two steps are really done for us. Step 2 is often done for us. We've yet to have to choose a level of significance. It's often given to us. And in this case, it also is given to us right there. Significance level of 0.05. So that's quite easy. And the test, of course, is a z-test for proportions. So those steps 2 and 3 are quite easy. Step 4 now, our decision rule. Well, before we can make our decision rule, we have to find our critical value. So let's do a little work here. What is the critical value? Now I call it Z and little sub CV. Okay? So, and we know that's inverse norm on our calculator. And it asks us for the area, and of course the mean of the standard normal, which is 0, and the standard deviation of z-score, which is 1, or z distribution. So area is alpha over 2, so it's inverse norm. Alpha is 0.05, divide that by 2, 0.02501. So let's go to our calculator now and do that. Now remember, distributions contain inverse norms, inverse t's. So in order to do that, we had to hit the blue button first, second, and hit the vars to get distribution. And I think it's number 3. Yep, there it is. Inverse norm. It's asking us for the area, 0.02501, and paste. We get -1 point. Now that's a common one. We've had that before in other problems. -1.96. Now it's two-tailed. How come we only have one critical value? Well, you don't. You have two. So right away, there's one. And the other one, of course, is positive 1.96. You only need to do one on the calculator, right? And the other one is the positive value of that. So there's the two critical values. If it's two-tailed, you need two critical values. So let's mark them in. So where are we down on our chart? Basically right here, almost 2, right? Let me do that again, a little bit sloppy. All right, it's -1.96 over here, positive 1.96. Now what does that mean? Again, it means this area, a little bit of area in here, from here down, is alpha over 2, which is 0.025, and this of course is going to be reject region, isn't it, for the null hypothesis? Because remember what alpha is. Alpha is the probability of rejecting the null hypothesis, okay, even though it may be true. So, and here we go. This is also the top tail or upper tail, 0.025, and again, anything in that region we're going to reject. So what's our decision rule? So if our z-score from step 5 is less than -1.96, then we are going to reject, or if it's greater than 1.96, right? So it's less than -1.96, or if z is greater than 1.96, we are going to reject the null hypothesis. Alright, let's run the test and do our conclusion. Now, step 5, okay, we actually run the two-prop, I think z-test it's called, which is 2-sample. Maybe let's have a look on the calculator. So stat, go across the test, yeah, and see down there number 6, 2-sample proportional z-test. So we go down to this, we click no. So all those formulas are entered in the calculator for you. We're doing it by calculator. Now it's asking you for x1. x1 is 64, number of successes in the group 1 or sample 1. N2 is 200. Okay, x2 is the number of successes, that's 92, so enter 92, and 200 for that. Now pick the correct tail. In this case it's not equal to, so enter and calculate. Now we see we get a z value of -2.87, so let me just write that down. Z, so our z test value, if you want, So I'll put little, whatever you want to call it. Some people just call it Z to distinguish it from the other one. 2.87. Now I'm going to write down the p-value here. We'll talk about the p-value after. 0.004. So where is negative 2.87? Okay, where is negative 2.87? Well, if we look at that on our chart, it's definitely in the reject region, isn't it? Negative 2.87, somewhere around here. Okay, so there's our Z test value, and therefore it's less than negative 1.96. Therefore, we reject the null hypothesis. So our conclusion: reject HO. It means we accept HA. Now, if we accept HA, what does that mean? Write that out in words. Accept HA. Okay, so let's look at that a little bit more closely. Accept HA. You should always write a word answer to a word problem, so let's write that over here. There is no difference, right? Oh yes, there is a difference. Accept HA. They're not equal. Look at that. So there is a difference between the medicated group and the placebo group. So yes, the medicated group, there is a difference. Between the medicated group, I'll just call it Medicaid, MED, and the placebo group. Okay, so in other words, medication is making some difference, isn't it? Now, the other one, of course, is the p-value, and the p-value here is an extra test, but look at it, 0.004. And when you're looking at p-values, remember, if p is less than alpha, is another reason to do not accept or reject the null hypothesis. And in this case, 0.004 is indeed less than 0.05. So we reject it, right, based on that. So it's an extra test, if you would, a probability test. Okay, so that's a complete solution for a two-sample proportional Z-test. That's it from me for now. Over and out.